This video will show you an actual live test of MOXA's new technology, fiber diagnosis, which provides a convenient way to examine network-wide fiber communications from a single location. Let's look at our test environment. We are monitoring a Profibus device on a PLC through fiber converters. On the top rail, there is a Profibus PLC performing device monitoring. It is connected to an ICF-1280I converter on the second rail, which forms a redundant fiber ring with two field site ICF-1280I converters on the third rail, one of which is connected to Profibus equipment. Now, in our lab, this entire test fits on a single rack, but in the real world, this system has enormous range between the Profibus master and the Profibus I/O because the converters are transmitting the Profibus packets over long-range fiber cable. Now let's look at some scenarios of how to use fiber diagnosis to examine network issues. When deploying a system, the first thing to deploy is the converters and fiber cables. At this point, the Profibus PLC is not yet installed. So how can we check the connectivity of the converters and the fiber cables if we don't have the PLC installed yet? Now, in the past, it was necessary at this point to send engineers to each location so that they can perform a simultaneous fiber connectivity test. MOXA's fiber diagnosis function empowers just one engineer to verify that the connectivity is working remotely from just one location, from one converter. What's more, fiber diagnosis also narrows down the location of any connectivity failures, if they do exist, to either a local port or one that's further away on the network. For our first test, we'll disconnect this cable from the TX port on the top converter. Then we will activate fiber diagnosis by flipping dip switch 8 to on. The ready LED will flash red while fiber diagnosis is running. It will turn green when the test is complete. Now the LED is green, it's flashing green, and we can see that the port 2 LED is solid red, indicating that there is a connectivity issue on the TX interface for port 2. Next, let's try the same thing with the RX interface on port 2. This time, we'll see a slightly different response from the converter to indicate that there's a different interface that's at issue. The port 2 LED is flashing red. The state of the red LED, flashing or solid, specifies whether the connectivity issue is on the TX or on the RX interface of port 2. Next, let's see what happens when the connectivity issue exists in a location that's remote from the converter where we are performing the test. In this case, we'll remove a line further down on the network, and we'll see that the fault LED is lit on our converter at the top, indicating that there is a connectivity issue somewhere on the network. Now we're in the operational phase, and the PLC is interacting with the Profibus slave devices through this redundant ring. The network redundancy is good because it allows the Profibus devices to continue to communicate down a backup cable if, for example, one of the fiber cables is accidentally cut. However, the PLC is only able to detect an error when the Profibus traffic has stopped completely, which means that the PLC will be blind to any cable failures such as this one because communications are continuing down the backup line. Luckily, with fiber diagnosis, the ICF-1280I can step in. Here, after we've disconnected the cable, we can see that all the LEDs on the Siemens Profibus device indicate that the communications are still normal thanks to redundancy. All the Siemens LEDs are still green. However, the LEDs on all the converters in this network will now indicate to us that there is an issue. You can even hook up an external relay alarm to the converter so that any connection issue is visible from far away.